Okay, good morning. Today we're going to working on the 15-minute student final presentation. And as we scheduled in Monday, there will be 6 presenters that going to talk about their selected topics. And before we begin, I would like to invite Fadila to show her presentation and check whether the connection is good.
Hello, sir.
Yes?
Is my voice clear?
Yes.
May I share my screen?
Yes, go ahead.
Okay. Is it already seen?
Yes, I have seen your presentation. Okay, before you begin, I would like to remind everybody to prepare the assessment sheet for Fadila and the rest of the presenters that going to talk in this session. And also for the presenters that already have their talk today, I would like you to upload your presentation file, whether it's in PDF or PPT, on the given folder in the EduNext. Okay, so let us wait for another minute before 5 past 7 started. Okay, and each presenter, I would like to remind every presenters today that you have 15 minutes. That includes the Q&A sessions. So I hope that you could manage your timekeeping in this final presentation. I will give each presenters a fair warning when they're going to exceed the time limitations, because everybody needs to post or involved in Q&A session. So therefore, make sure that you could manage your presentation time. Okay, without further ado, I would like to introduce you to the first presenter, which is Fadila Rizatul Yahya, which is going to talk about the analysis of stocks of the PT HM Sampurna Terbuka. Okay, the floor is yours.
Okay, thank you to Mr. Hari Mahardika. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Everyone, my name is Fadila Rizalul Yahya. My ID number is 102, 18, and 55. Today, I'm going to present you about my study that is entitled Analysis of Markov Chain Application on Stock Trend, Study Case of PT HM Sampurna.
I'm sorry to interrupt. Could you turn on your camera, please?
Wait, sir. May I continue my presentation?
Yes.
Okay. Stock market in general is one of the attractive field for investment, especially in Indonesia. Indonesian stock market has continued gradually to move to its best state, as we can see here in the screen, of about 25% of Indonesia's stock market rises in the total number of single investor identification over a year in 2016. SID stands for single investor identification. It is the investor identity number published by KSAI to allow people register as an investor. Based on this data, people are now looking at investment on stock market, and they could make choice to do a good investment as they want. So to consider stock market for investor taking the opportunity, one of method to analyze the trend is by using Markov chain method. This method based on future expectation of the stock market. Therefore, the study conduct the analysis of stock market trend movement. The model used, that is Markov chain model, has been widely applied to analyze the stock trend. It is determined by using probability transition matrix and initial state value. Markov chain model also provide an overview by stock price present state value about the movement in the future. Here the stock market trend. Trend in stock market is a pattern. Either it is up, down, constant, or so on, over a certain period of time. In investment analysis terminology, Semenov in 2017 said that a trend is seen as a price movement that lasts long enough to be defined and is still tradable. Here in figure 2 shows the pattern of the trend. We can see the ups, the downs, and so on. As to analyze stock market is used to see the changes and movement in current time and in future. Generally, method to analyze stock trend can be divided into fundamental and technical. By fundamental means approaching fundamental data of companies such as financial report, balance sheet, cash performance from cash flow statement, or the statement of profit or loss. And by the technical, based on market behavior in certain time, and also by historic prices of range of time. Moko in 2009 said, in technical method, it is based on what happens in a market that is not affected by any political issue, economic phenomena, or so on. Next, here in Markov chain method, Markov chain using current state value of stock market to determine future occurrence of any event, and the future depends on the present state. One of the advantage is it is easier to predict the possibility of state value in a certain period of time. Markov chain using parameters that are states, the initial state distribution, and state transition probabilities. The work principle of Markov chain method is first calculate the initial value as state space, and then calculate state transition probability, and then predict the possibility of state value. Definition of Markov chain itself is we let variable x to be a stochastic process that take on a finite of possible values. If the x n equals to I, then the process is said to be in state I at time I. Whenever the process in state I, there is a fixed probability Pij that will next be in state J. To gain more understanding about this Markov chain method, let us see the simple one. I like to start with an example. Assume there is a restaurant that serves only 3 kinds of foods: hamburger, french fries, and pizza. The restaurant obeys a weird rule. On any given day, they serve only of these 3 foods, and it depends on what they had served yesterday. In other words, there is a way to predict what they will serve tomorrow if we know what they are serving today. For instance, first, there is a 60% chance that tomorrow will be a French fries day, given that today is a hamburger day. Here, The diagram represents as weighted arrows originates from the current state and points to the future state. And in the left one is all the possible transition. Mathematically said, n plus one step will be j depends only on the nth step, not the complete sequence of steps that can be for n. And there are one here. It is called transition matrix named A. The weight of the edge connecting the two corresponding vertices. For example, the element in second row and first element denotes the weight of the transition probability from French fries to hamburger. If an element is zero, then it just means that there is no edge between the two. After this, the goal is to find the probability of each state. Suppose in the beginning, restaurant serve French fries, so the matrix have element 1 on the second element. When this pi is multiplied by the transition matrix, then after a certain point, the output row vector should be exactly same as input vector. It is denoted as pi a equals pi. The element of pi must add up to 1 because it denotes a probability distribution. So after solving these two equations, then we get stationary state that tells about restaurant will serve hamburger about 25 of 71, French fries about 15 per 71, and pizza about 31 per 71. Next, the collection of data. In the study, I used stock data from PT Hanjaya Mandala Sampurna. The data is the cost price of the stock collected from period of 1st January 2017 until 31st December of 2017 from Yahoo Finance. Continuing from part of how Markov chain works, the method overall are: first, we choose a company stock market or company target stock prices. Secondly, we collect the data from any sources period are available. Then the data is divided into 4 states or categories. Then we analyze data information by using Markov chain. There are constructing the state process and determining the state probability, determine state transition probability matrix, calculating state probability, analysis to decision making in stable connection. From that, we get the model and get the conclusion. Figure 3 here is the plot of stock price from given period of time. Data is classified into these 4 states or categories. From that classification, the transition matrices we got for those states are formed as P. Then from this variable P, there is transition matrix. We get the stationary distribution. Before we let initial state factor as I1. After the initial state factor, it needs to find the next factor. As here it used for state, then it needs to find the state factor from 2 to 4. There are I2, I3, and I4. Then the stationary distribution will be constructed from the state factor as before created as variable S. From the result, steady state factor is found in the matrix multiplication. It is become steady state factor, so we get pi 0, pi 1, pi 2, and pi 3. It interpreted as the probability of going up high is 9%. The probability of going up low is 40%. Probability of going down low is 46%, and the probability of going down high is 5%. As mentioned before, we know that the objective of this study is to use Markov chain model to analyze the stock trend regarding the movement of stock index to various states and a particular day with an initial days, but depends only on the index of the most recent day. The steady state probabilities are obtained from the end state transition probability matrix, shows that the chance of PTHM Sampurna index to increase is 0.09 and 0.4. The probability that index will decrease is 0.46 and 0.05. So it is interpreted that 9% and 40% increase and 46% and 5% decrease. This study classified increase with going up high and going up low, and also decrease with going down low and high respectively. Thank you for your attention. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Okay, I would like to invite questions from the floor, from the audience, if there are any. Yes, please. Darmina?
Yeah. Does my voice sound clear?
Yes.
Okay. Thank you, Rizal, for the explanation. I am Narmina. I have two questions. The first question is about the initial factor. What's the number come from any calculation? And the second question is using this method always give this best result when it comes to analyze stock trend or not? There are my question. Thank you.
Okay, you may answer the question.
Okay. First, I want to clarify the question. The first one is about the initial factor that's stated here in my slide. Actually, it comes from the ratio between amount of frequency of certain state divided by the total amount of index. Here we have 4 states, and the index is 240. So the initial state factor comes from the ratio between amount of frequency of certain state divided by the total amount of index of stock price. In the paper, for the initial state probability is calculated that state 1 is 21 per 240. It becomes 0.09. State 2 is 93 per 2040 becomes 0.39. State 3 is 110 divided by 240 becomes 0.46. And the last one is state 4. That is the ratio between 12 per 240 becomes 0.05. And for the second question, that is about is this method will give best result? As I read this part from the sources, it says that this method sometimes give another understanding. There could be a way they use to know further detail of the stock price. And from the sources says from the sources I read, it is sometimes use fundamental and technical way first. After that, using another method like statistical description or statistical inference. And after that, they could use this method, this Markovian method, as an additional method or an optional method to analyze stock price. That this method have an advantage that gives a statistical approach about future occurrence that is determined by present value. That are my answer for the question from Nermina. Thank you.
Okay, is that answer your question, Nermina?
Yeah. Thank you, Rizal.
Thank you.
With that, I'm going to applaud Fadila for giving the first talk of today's session. And thank you for your discussion. And then we are going to move on to the next presenter, which is Rati Pratiwi, who's going to talk about CO2 storage and enhanced gas recovery in unconventional reservoir. Okay, I would like to remind all of the presenters today, don't forget to use your pointer that is already embedded in the PowerPoint. And then each presenter is asked to turn on the camera so that we can see the face of the presenter and making eye contact with the presenter. Okay, whenever you're ready, Rati, you may start your presentation.
Okay, sir. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Rati Pratiwi. Here I'm gonna present to you about monitoring carbon dioxide storage and enhanced gas recovery in a conventional Chattanooga shale reservoir. As the background of the study, as one of the sources of energy, natural gas can be used in various ways, and one of the benefits of natural gas is to generate electricity. And as we can see in Figure 1, natural gas accounted for 40% of total utility scale US electricity generation in 2020. And Figure 2 tells us the US electricity generation by major energy source from 1950 to 2020. 1,617 kilowatt hours of US electricity generation is coming from natural gas in 2020, as we can see here. Okay. Based on the locations of where the natural gas can be founded, there are several types of geological formation that trap natural gas, namely conventional and unconventional gas reserves. Conventional gas is trapped in naturally porous reservoir formations capped by impermeable rock layers, so gas can move to the surface when intercepted by a well without needing to be pumped, whereas unconventional gas is formed in more complex geological formations that limit gas migration ability, so it requires different methods to extract the gas. And there are several types of unconventional gas, including shale gas, tight gas, or coal seam gas, or also known as coal bed methane. In this study, what we're going to highlight is shale gas. Okay, and about the carbon capture and storage, natural gas production is one of the large point sources of carbon dioxide emissions. And to reduce that emissions, here stands carbon capture and storage as a mitigation action. In Figure 4 here, a huge mass of carbon dioxide is injected into the reservoir for enhancing the gas recovery. During flooding and or having process, some amount of carbon dioxide get trapped in between the pore spaces. Okay, so the objective of the limitations of this study, I will explain the objective first. That is to analyze the potential of carbon dioxide storage and in shale formations while monitoring for enhanced gas recovery in unconventional shale reservoirs. And the limitation of the study are The study area has an organic shell lithology located in Chattanooga Formation, and the selected well candidate is a horizontal well owned and operated by CNX Gas. And the last one, the injection scale is a small scale carbon dioxide injection. Okay, so here I will explain about the project procedure. We have to do a site characterization first by conducting geological assessment so that we can select the injection well. Next is the MVA, or monitoring, verification, and accounting. And then we can see what is, I'm gonna talk a little about monitoring, verification, and accounting. Here is, there are 13 nearby offset production wells that were selected as monitoring wells. And the next procedure is to prepare the site so we can facilitate the site of carbon dioxide injection. Then the last but not least is the carbon dioxide injection itself. Okay, as part of geological assessment, we can see the regional stratigraphic relations in figure 6 here. This line, the AA prime line, is a strike-oriented line, and the BB prime line is a deep-oriented line. So the Chattanooga shell regionally strikes to the northeast and deep to the southeast within the study area. There are 6 injection well candidates located in Anderson and Morgan counties, as we can see the dots here. There are 6 dots. And in figure 7, we can see a generalized stratigraphic column for Devonian and Mississippian edge rocks in the Chattanooga shell study area. And it can be seen that the formation of this study area is this Chattanooga shell, of course, with an organic shell lithology, which is covered by the Fort Payne limestone formation and is above the Rockwood formation. Next is the site selection. Based on review of factors such as road accessibility, size of the well pad for equipment, transportation, and etc. and so on, horizontal well owned and operated by CNX Gas was selected as the candidate to facilitate a small-scale carbon dioxide injection. In January 2019, the injection well was brought online as a natural gas producer, and it had averaged 40,000 cubic feet per day of gas over its lifetime. And in the last year of production before the well was taken offline, the average daily production was 14.7 thousand cubic feet per day. Okay, move on to the next slide about the monitoring, verification, and accounting. There are 3 horizontally drilled wells and 8 vertically drilled wells completed in the Chattanooga shale. Also 2 vertically drilled wells completed above the Chattanooga shale. So the HW means the horizontally drilled wells, and the VW means the vertically drilled wells. We also need data of gas composition, historical gas production, and wellhead pressures of this offset production before injection. Okay, next is the site preparation. This is the layout of carbon dioxide injection well site. The road to the well pad were re-gravelled and graded to facilitate carbon dioxide delivery by truck to the injection site, and a 70-ton storage vessel was permanently stationed on site and refilled periodically by 20-ton tankers. The skid pump with all the controls and methods, as well as the propane tank and heater for heating carbon dioxide, was also located on site. Okay, during the injection, in every 30 seconds, the operator collected flow rate, temperature, wellhead pressure, and total cumulative tons. And here in figure 11, we can see the carbon dioxide injection data. The average flow rate was 40.95 tons per day, and the average heater output was 48.59 degrees Fahrenheit. Okay, in this section, I will talk about the results from this test that will be presented in 4 distinct phases of the project. The first phase is the pre-injection baseline phases. The composition and pressure data were collected periodically 5 months prior to the injection. And the injection phase tells that there was no significant change, tracer detection, and significant increase in carbon dioxide concentration at any offset production wells. And About the soaking phase, we have here the figure 12, about the wellhead pressure during soaking phase. We can see that the wellhead pressure after the injection phase was above 500 psig, and it decreased to 260 psig in 3 months. In this phase, there was no significant increase in carbon dioxide concentration at the offset production wells, and gas stream averaged over 97% of carbon dioxide. Okay, the last phase is called the flowback phase, where the well was put back into normal pipeline operation. This figure, the 13th figure, displays the gas compositions of HW1003 during the flowback phase, which are carbon dioxide, total hydrocarbons, and nitrogen. Figure 14 displays the individual hydrocarbon chains and the percentage of the total hydrocarbon composition during the flowback phase. And the composition of more valuable natural gas liquids was directly correlated to the composition of carbon dioxide, while the composition of methane was inversely proportional to the carbon dioxide. And carbon dioxide mobilized the NGLs into the gas stream, where the heavier hydrocarbon create the effect. Okay, figure 15 here displays figure 15 and 16 here display the production history, the injection and soaking phase, and also the flowback phase. During the first months of flowback, the average daily production rate was 123.9 MCF per day, which is over 8 times the average production before the well was taken offline for injection. And after 2 years of flowback phase, the well is still flowing, and it increased production. And the well is still flowing at an increased production rate, but it is just close to the production historical. What is this one? The production rate is close to the projected historical production rate. Okay, next is the conclusion of this research. So based on the results, the injectivity of carbon dioxide into fractured organic shell reservoirs is confirmed, and if the injection well was shut in after carbon dioxide injection, complete and permanent geological carbon dioxide sequestration could have been achieved. And regarding enhanced hydrocarbon recovery, the natural gas liquids composition was correlated to the carbon dioxide composition, and the heavier hydrocarbon, the greater the effect. So based on the 3 aspects here, we can conclude the main conclusion that the 510 tons of carbon dioxide injection test reveals the first successful carbon dioxide injection in an organic shell formation to monitor for storage and enhanced gas recovery, or EGR, potential in Central Appalachia. Okay, that's all for me. Thank you for your attention. If there's any question, just kindly ask. Okay, thank you.
Okay, thank you, Rati. We have time for 3 questions. Is there any question from the audience, please? Okay, so in this study, there are no geophysical measurement to monitor the sequestration process?
To monitor the sequestration process, there are several analyses on each phases, like the pre-injection baseline, the injection soaking, and the flowback phase.
And these are basically procedures in oil field or gas field operation, right? So
gas, especially
the operation is that if you have increase of pressure or any variables in CO2, it means that there will be so if you are producing oil or gas, it means that and it is based, and the production is increased due to the fact that you are injecting CO2, it means that the operation of sequestration is successful. more or less?
I will clarify that this research is when we use the a kind of depleted shale gas to inject carbon dioxide, and the benefit of it, one of them is to reduce the emissions of carbon dioxide. So when we can use the depleted shale gas as the storage for carbon dioxide, so we can analyze several phases as I mentioned before, and it shows that the capability of the injection site is in this soaking phase I will explain a little bit of the capability of the injection site to storage the carbon dioxide. So it has 97% of carbon dioxide storage. I mean, the injection site can store the 97, I think, 97% of carbon dioxide there, and there was no significant change to reservoir detection and significant increase in carbon dioxide concentration at any offset production wells, as the offset production wells can be used as the validation on is there any leakage of carbon dioxide or not. So because we can see that there was no leakage there, I mean, the 97% is a big percentage. So we can conclude that the injection of carbon dioxide there in the injection site is quite successful.
Okay, so it means that.
Yes?
I'm sorry to interrupt.
Yes,
okay, so
I can conclude that the injectivity of carbon dioxide into fractured organic shale reservoirs is confirmed.
Okay, to clarify, the Chattanooga shale that we study here is a active production well, or it is already? There are no more production in this well.
Since the injection site is turned off, I mean, turn off means
you say that it is a depleted well, right?
Yes, we can.
So is it still producing gas, or no longer producing?
I think now it's no longer producing.
Okay, so in the past they are producing hydrocarbon gas, but now they're going to fill the reservoir with CO2 to replace that gas. So that's basically what the aims of this study is.
Yes, we can say that.
Okay. Thank you, Rati, for the discussions. I would like to applaud Rati for giving a very tremendous talk in this session, so that we could proceed to our third presenter, Muhammad Raka Fauzan, who's going to talk about saturation modeling and estimation for porous rock models. Okay, don't forget to turn on your camera. And you may start whenever you're ready.
Okay, thank you, Mr. Hari. So, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. First of all, let me thank Mr. Hari Mahardika for inviting me here and for all audience that coming here today. Let me introduce myself. My name is Muhammad Raka Fauzan from Physics of Earth and Complex System Research Division. Today I want to present about my research paper about water saturation modeling and estimation of electric property in porous rock models. So first I want to begin with a question. How can we understand what is happening beneath the Earth's surface? In exploration of geophysics, physical properties of rock is really important thing to understand what is happening beneath the Earth's surface. Digital physics is a digital-based method to obtain rock physical property and visualize rock microstructure more efficiently and effectively. With advance in computer technology, it has become visible to compute microscopic physical property of porous rock from its microstructural information using rigorous numerical simulation of physical experiment in realistic pore space geometries. The numerical approach allows one to study property of complex multi-phase material with physically realistic phase distribution. However, computer simulations are not exact and their accuracy is limited by the simulation algorithm and by computational parameters, such as spatial discretization. Therefore, in order to optimize the computational parameter, it is important to test the result of such simulation against non-regular solution. So there are some physical properties of rock such as elastic properties, electric properties, and magnetic properties. This physical property can be affected by certain factors such as microstructural complexity, electric properties, pore geometry, and also water saturation. In this paper, we choose water saturation and elastic property of rock for our parameter to understand the relation between them. We propose a task scenario for a numerical simulation for a medium saturated with a fluid mixture. The goal is to determine computational parameters that ensure accurate and robust simulation. Next, as we can see from the equation in this slide, water saturation defined as ratio of water volume to pore volume, and it can also be calculated from effective porosity and resistivity. It can be described as formation of water in undisturbed zone and the ability of solid to hold a great amount of water under specific condition. In figure 3, we can also see the example of water saturation model that we will use. This model morphologies were generated using a simple Boolean overlapping spheres method for various degree of saturation, ranging from dry to fully saturated condition with porosity approximately equal to 0.25. We use image in binary form with 1 and 3 assigned to the voxel that fall into the fully connected pore space. The present gas is a black color and water is the white color. And the gray is the quartz or the solid phase. We consider two models with different distribution of fluid phases. The locally patchy model in figure 3a is the left one, as uniformly distribute fluid patch, where macropatchy model in figure 3b, the right one, contains single spherical enclosure in the middle of the pore system. Can we see this? Can see the slide? I'm sorry. So now is the bulk density of a substance is a measure of how resistant to compression that substance is. In this case, we are looking for the effective modulus of the rock known as Gassman-Wood and Gassman-Hill or GS limit from Johnson 2001. This equation is applicable to the scenario where the medium saturated with a fluid mixture. We get this equation from derivative of Gassman equation, Wood formula, and Hill average. Next is we're gonna talk about the method of this paper that we use. So to help us study about the relation of water saturation and elastic property, we will use computation of elastic property using numerical modeling. Program of water saturation modeling will analyze by numerical method developed by Gattuso in 1998, namely finite element method, It will discretize the model into smaller amount that consists several nodes. Then the solution approach is determined by the value of this node. In this slide, we can see the example of the 3D model of quartz and the example of the element of node. Element is content of the cubic space, and node is the black dot at the corner of between the corner and points. So the black dot is the node. The finite element method will discretize the 3D model and turn it into several elements and node, then analyze the value of this node using several equations. And this is the parameter that we use in the experiment taken by Markov et al. In 1998. This parameter contains three phases. As for solid, it's quartz, liquid is water, and gas is an empty room in the porous rock. So how exactly are we going to do this? So in this paper, we set the test scenario of numerical prediction of the effective elastic model. First, we perform the numerical experiment for Boolean random model of quartz saturated with gas and water. Then we verify it, the Wood formula of a fluid mixture with no solid phase. So the gray one is didn't include in the analysis. In the next set experiment, we focus on model of partially saturated idealized materials with regular geometry. Then we investigate the effect of pore channel size and the total area of the gas interface on numerical prediction. Finally, we examine the effect of spatial resolution of the image on the finite element method code performance, and then we will get the conclusion of it. In the next slide, we will talk about the result of the numerical experiment. So the result of numerical experiment performed for the Boolean model are demonstrated in figure 6. The predicted effective elastic modulus should be the same for both model and agree with the Gassman-Wood theory. However, the numerical estimates show significant difference between the fluid model and both disagree with the Gassman-Wood limit. So as you can see in here is we have local patchy and macro patchy model, but it's not following the equation from Gassman-Wood and Gassman-Hill. So there are still significant difference between them. And we try to verify it with the Wood formula by testing the finite element method code on model with two free fluid phase, water and gas. So in this scenario, we have three phase is water, gas, and solid. And in this, we're just using two free fluid phase, it's water and gas. So the Wood formula use a concept of a compressible homogeneous pore fluid to treat a fluid mixture, each component of which is assumed to have same stress. We can see the result of this in figure 7 that show us the excellent agreement of both model with Wood formula. So for now, it's the center and the random. It's following the line of Gassman-Wood. And they prove the capability of the finite element method code to predict the effective elastic modulus of a fluid mixture. This result suggests that in the presence of solid particle, the finite element method simulation failed to equilibrate fluid pressure. The possible explanation for this is an insufficient number of finite elements across thin fluid channels. Next, we want to explore the extent of which small and voxel pore connection can be resolved properly by the finite element method code. So in here, we conduct numerical experiment on the image of idealized partially saturated rocks. And here we have 6 channels. Here in figure 8, we can see the idealized partially saturated rocks. The blue volume represents the gas filled pore space, and the red volume represents water filled pore space. And the transparent part is the rock frame. In figure 9, we compare the result of 3 sets of experiments with different cross-sectional area of the channels, ranging from 4 element voxel to 900. So this 2 voxels, 10 voxels, and 30 voxels. Plots A and C. Answer C, so finite element method estimates of effective bulk moduli at the black circle versus Gassman-Wood solid line and Gassman-Hill line. This is the Gassman Wood, and this is the Gassman-Hill. I'm sorry, and this is the Gassman. And the panel D show the central slice of fluid pressure. So we cut this in the center slice of the fluid pressure at the end of relaxation process. And from this figure, as we can see, for the model with the widest channel and consequently the largest total contact area, the widest channel and consequently the largest total contact area between the fluids, finite element method code yields results which are in excellent agreement with the Gassman-Wood limit, demonstrating that the pressure field is fully equilibrated. So in here we can see the process is the pressure in the water and the air area is fully equilibrated. So in order to obtain reliable numerical estimate of the effective elastic parameter, we need to control the total area of the fluid interface and the channel size. Figure 10 show that the higher resolution numerical estimate calculated for the 2166 channel model provide better agreement with the Gassman-Wood theory. The output of the fluid pressure slice demonstrate better pressure equilibration for this case. However, the increased spatial resolution for the model with 600 channel does not provide.
I'm sorry, but you have 1 minute to conclude your presentation.
Okay, I will just continue to my conclusion then. So basically in here, we have okay, let's just continue. So from the numerical experiment that I have explained before, we conclude that the numerical simulation have shown that the computed effective moduli depends significantly upon a pore geometry and the size of fluid patches. The increased spatial resolution of digital images generally improve the numerical results. The number of voxels determine memory requirement and the CPU time. And the result of the numerical simulation confirm that the finite element method code is capable of predicting the linear effective elastic property of partially saturated rocks, with the accuracy of the result depend on how well the digital model of material are resolved. So this will be the end of my presentation. If you have any question you'd like to ask, I'll be happy to answer. Thank you.
Okay, thank you, Raka. Questions from the audience? Okay, could you clarify the table that you present in slide 7?
Slide 7 in here.
Okay, so this numbers is coming out from Gary Mafko's book, right?
Yes.
Okay, so it's actually coming from Rock Properties Handbook of Gary Mafkos and authors, and then the other one, the properties that mentioned below is water, right? It is not water, right?
Oh yes, it's water.
Okay.
I'm sorry for the mistyping.
Okay. Okay. Question from the audience. Okay, for the finite element method that is proposed in this study, do the pores and quartz distribution is randomly given, or do you orientate the position of the matrix and the pores into a certain configuration?
Oh, yeah. So in this slide, I'm just giving the example of the Quartz 3D model. It's not the model that we use used in the paper. So in this paper, what we use is the local patchy model and the macro patchy model. And the macro patchy model is single circle, black circle in the middle. And the local patchy model is a single smaller black circle, but it distributed in the model.
Okay, and then the but the gray area, the black and the white area, you make it random, the distribution, or you specify that this node is patchy, this node is quartz, and this one is porous?
I think from the paper that I read, it's have a random generator, just the black and the white one is the, I think it's the water and the air, but as we can see in this picture that they have the same solid, they have the same solid position distribution. So
Okay.
I think we just vary the distribution of the air.
Okay. Okay. Thank you, Muhammad Raka, for your presentation. So for our time effectiveness, we're going to proceed to our fourth presenter, which is Rifki Nafis Mubarak, that is going to talk about wastewater cleaning robot. Okay, don't forget to turn. Okay.
Can you hear me?
Yes. Yes. Clearly. Okay, you may start whenever you're ready.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, Mr. Harry and everyone here.
Morning.
It's nice to meet you. Thank you so much for the time. Let me introduce myself. My name is Rifki Nafis Mubarak. I'm a student from Instrumentation and Computational Group Physics Study Program, Institut Teknologi Bandung. Today, I will introduce my final assignment entitled Water Waste Cleaning Robot for Waste Management Project in Chittaron Harum Action. Moving on. Now, there is a question here. Is Chittaron River one of the most polluted river in the world? Although it is a bit controversial, the Chittaron River is indeed polluted. In fact, 3 out of first 5 related terms that came out if you search dirtiest river in the world are Chittaron. There are so many articles that count the Chittaron River as the most polluted river in the world. As you can see at the picture, there are so many headlines to the Chittaron River being polluted and unsafe to people. Even according to the Guardian, and I quote, many people suffer from dermatitis, contact races, intestinal problem, delays in child development, renal failure, chronic bronchitis, and a significant incidence to tumors. According to the Professor Diego Ramirez Lowering, the director of the Informal Cities Lab and Monarch Art Design Architecture Australia, said that water quality across most of the river has been deemed unsafe for human use. With the Asian Development Bank finding levels one of the dangerous bacteria to human and animals, faecal bacteria, more than 5,000 times the mandatory limit. And the lead levels far exceeding the U.S. Environmental Protection Agency drinking water standard. So, next question is, why is Chittaron River one of the most polluted river in the world? For that, let me tell you what is Chittaron River, how big it is, and why is it very important people living near the river. As you can see at the picture, Chittaron is the longest and largest river in West Java. running 270 kilometers through thousands of communities to connect the people, villages, and landscape of the most populous province in Indonesia. It supports the food, water, electricity supply for 25 million people, irrigating hundreds of thousands of hectares of rice field and supplying the nation's largest reservoir. Oh, why is the Chittaron River so polluted? There are several reasons that cause the Chittaron River to be polluted. The first reason is the large number of people who live close to the river. We know that West Java is the most populous province in Indonesia. Because of that, many people live near the water source, do not keep their sanitation very well. Then the second reason, there are so many industries that stands near the rivers, throw their waste into the river, such as textile files and so on. And then the reason number 3 is household waste, where this waste is very much produced by settlement that do not have permit land or belongs to the state and is not covered by the national garbage disposal system, so they throw the garbage into the river. And next, there is lack of education. This reason may be a little controversial, but it cannot be denied that low education makes residents who live near the rivers not realize how dangerous it is to pollute the river. And then the last reason, we have waste management, a bad waste management system, or the government is reluctant to take care of household waste and industrial waste disposal system that live near the river. So how do we solve these problems? In 2018, the Indonesian government established the Chittaron Harum, a 7-year river revitalization program with the goal of making Chittarum's water drinkable by 2025. The program has been supported by the International Monetary Fund and the ASEAN Development Bank and include foresting surrounding mountains, extracting toxic sediment, regulating water waste discharge, and environmental education project. There are 12 programs in the Chittaron Harum Action, including several solutions that answer some of the problems I mentioned earlier, such as education and community empowerment in handling domestic waste and handling industrial waste. But in this occasion, I will only discuss one project that related to my final assignment, and the project is waste management program. According to the Chittaron Harum website, waste management is a systematic, comprehensive, and sustainable activity that includes waste reduction and waste handling. This program consists of 2 parts. First, namely human resources as the river cleaning agent, and the second part is the equipment to clean the river. My final project focuses on the equipment for cleaning the river, and the name of the project is a waste cleaning robot. As you can see at the picture on figure 3, on the left side, it is one of the robots made by physics student from Institut Teknologi Bandung in 2019 by Miss Haima Armisti, who has the same project as me, making a robot for the Chittaron Harum Action. And then in the picture on the right side, it is a GIF taken from YouTube, and the simulation of the robot on the right side is similar, more or less the same as the robot made by Miss Yama. So, how does the robot work? As you can see on the screen, there is a flowchart that explains how the robot works. First of all, at the start, we turn on the robot via the remote control. Then the next part is to check whether there is garbage or not. The flowchart, I call it as object. If yes, we activate the conveyor and we lift the object to the trash can. And then after the water level sensor shows the limit level for the robot to float, then we go to the garbage collection point or waypoint and send it to the appropriate coordinates. If it doesn't show the water level that goes to the ship's limits float, then the robot will continue to collect garbage up the specified water level limit. And then the robot will continue to search the garbage and do it repeatedly according to the loops here. So, how do we make this robot? Based on the picture that you guys can see on the screen, this is a mechanical framework for the robot to be built, which consists of a brushless DC motor that moves the robot from the back. Then there is a conveyor, a DC motor that can move the garbage, to lift the garbage from the surface of the river to the trash can. Then there is a trash can to collect the garbage that has been lifted. And then there is a box containing electronic component. Then on top of this mechanical framework, should be a solar panel that capture sunlight and store energy in the form of stored batteries or accumulators to provide power to provide power to electrical component. In this picture, you can see the front view, the top view, and the back view of the robot. It will be the shape of the robot's mechanical framework that will be made. Then the next slide, we have the component of the robot. There are three major sections that build the robot. The first section is the power supply, consisting of solar panels and accumulators to turn on the robot to work in the middle of the river. And then there is a power bank to turn on the remote control. In the second section, there is a transmitter part, which function as a remote control consisting of Arduino as a microcontroller. Then there is a joystick as a driver and a radio module as a signal sender to the receiver. Furthermore, the receiver section consists of Arduino as a microcontroller and the brain of the robot itself. And then there is a radio module, the receiver section to receive information sent from the transmitter. Then there is a DC motor to move the conveyor and move the robot. And then there is a water level sensor to identify whether the garbage contained in the robot is full or not. And then the next slide is the transmitter section. The simulation of this section is that first, the power bank will power the Arduino as a microcontroller in the Arduino. We create a program, give command to send signal from the remote control or joystick and send them via the radio transmitter module to the receiving section or the robot itself. The application used to create the program in Arduino is a C programming language. Then Arduino will send a signal to the remote control that we made so that we can send information to robot that is working in the middle in the river through the radio transmitter module. And then the next slide, we have the receiver section. The robot or the robot itself consists of power supply, which are a solar panel and a battery or accumulator. There is a radio module or a server that will receive information and then send it to the Arduino. And the Arduino, or what we call as the brain of the robot, it will process the signal and forward it to the such as motors that are moves the robot and moves the conveyor. There is also a water level sensor to check whether the robot has accumulated all the garbage, and then also there is a motor driver as a module to control the running of the robot. And this is the data result after we collect some data or the output from solar panel according to how much time we spend to charge based on the curve, output voltage versus time in the left part and the picture, and then in the right side, this is the output current versus time curve. The effective use of solar cells for charging batteries is in the morning and afternoon condition. When the weather is sunny and not cloudy, the output voltage reach the maximum output voltage value. As you can see at the picture, the black and red one. Meanwhile, during the afternoon toward the evening, the output voltage is to near zero, and the output current also approaches to zero. This is because the exposure to the intensity of sunlight on the surface of solar panels or solar cells is getting less and less. This is the conclusion. The first conclusion is for the waste cleaning robot assists in accelerating the revitalization of the Chittaron River with the benefit of efficiency and utilization of technology, and assisting waste cleaning agent in carrying out river cleaning task. And then the second conclusion is based on the value of the output voltage and output current curve of solar cells against time. The best output voltage and output current value for charging batteries are in the morning and afternoon condition. To be specified in the data, it will be best if we charge in the 8 a.m. until 3 p.m. I think that's all from me. For more information, if you are curious, you can contact me via email down below, or you can ask me later or after this explanation. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Back to Mr. Harry.
Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you. Question from the audience, please. Yes. Rivka?
Thank you, Rifki, for the explanation. I have two questions on the slide 4. First question is, why do you use animation from YouTube and not from the Miss Kaimah one? And second question is, can you describe how the robot works in a simple way or in general? Thank you.
Okay, so let me clarify the question. The first question is, why do I choose the picture on the left side from YouTube, right?
Yes.
Okay. The reason I take this GIF, or it is actually a video from YouTube, and I cut the video to make a GIF so that the storage of this file is not too big. The reason I take this GIF or video is I just want to show you the video is how the robot works. This video from YouTube was taken because I do not have a video simulation from Miss Hayamawan, because this is pandemic, so we can I'm not able to enter the campus yet, so the simulation of the robot itself hasn't still make I'm not I can't do the simulation because of pandemic. I think that's the answer. And then the second question, how to describe the robot work in a general way. Okay, the garbage cleaning robot is used to on the surface of the river. First of all, the robot used in the surface of the river and serve to transport garbage the surface of the river so that the garbage can be transported and taken to the garbage collection point. In general, this robot consists of a tripod. Yes, the conveyor. So first of all, we detect the garbage and then lift it via the conveyor and then move it to the trash can. And then if the water level shows that the robot have limits already reached the limit into float, then the robot will send the garbage in trash can, the collection point or waypoint. I think that's the general work of the robot itself. Rivka, thank you. Your questions.
Good. Is there any more questions from the audience, please? We have time for one quick question for Rifki.
I want to ask a question, sir.
Yes, please, Muzaki.
I see that on the robot that you now protect some circuits outside the box panel. Is it safe? Some electronic part not put in the box. Thank you.
Oh, okay, thank you. Yes, it is unsafe if the electronic part is outside of the box. So actually, last weekend we meet with the my supervisor, Miss Nina. Miss Nina told me that it is better if all the electric component placed in one safe box, so it can avoid from water or raining, for example. So yeah. This picture on the left side is not mine, so that is advice from my supervisor. It can be better if the component is in one box.
Okay, I hope that clarified the question. And due to the fact that we are tight in schedule, I would like to applaud Rifki for his presentation, so that we can move on to the next presenter, which is Mr. Muzaki himself. Okay. Okay, whenever you're ready, Muzaki.
Good morning, everyone. My name is Muzaki. I'm from Instrumentation and Computational Physics Research Division. I will present my current research, which is low-cost tensile strength tester for nanofiber mechanical properties. The outline of this presentation, first one background, second one literature, third one measurement methods. In the background, nanomaterial are material that have one-dimensional size between 1 to 1000 nanometer. Nanomaterial have extraordinary mechanical and chemical property. Among all nanofiber, the nanofiber is of the nanomaterial that have the most application. Nanofiber are used in air filter, and since the COVID-19 outbreak, the demand for excellent face mask has increased due to its increased public awareness of the danger particle and bioparticle in the air. And nanofiber also used in water filter, protective cloths, bandage, and drug delivery. And to know that nanofiber is strong enough to use in that application, we need to test the mechanical properties of nanofiber. Mechanical property that we find are stress, strain, Young modulus, and ultimate tensile strength. And tensile strength tester machine was used to perform the mechanical property of nanofiber. There were two types of machine, namely hydraulically power and electromagnetic power engine. In this research, I will use electromagnetic power because it's easy to control it. And in this study, the machine has to clamp, and it has load cell to measure the force that we apply to sample, and linear gauge, and then electronic board and graphical user interface. The purpose of this paper is to find optimum load cell. So the load cell will be not too big, and it will be not detect force when test ongoing, or too small. And it will be overload. Gauge length of the actuator, design efficiency, and low noise electronic board. Moreover, how to treat nanofiber when it tests and the area of fiber in the test. In the mechanical test, we need to calculate the stress strain of the sample, and will plot as shown in this figure. Stress value was affected by tensile force applied to the sample, and strain was affected the increases in length. Young modulus can be calculated after getting the stress value at several points by looking for linear regression from point 0 to the yield point. Furthermore, UTS can be calculated by the maximum stress value of the sample. So to get mechanical properties, required force and length increase. First is calculated using load cell, and there is two literature that Wang et al. Use 10 Newton load cell, and Tarus et al. Use 100 load cell. The load cell is made of aluminum alloy and has 4 strain gauge. It converts a force such as tension, compression, pressure, or torque into electrical signal that can be measured and standardized. However, the maximum signal output is only 2 millivolt per volt. If a 5 volt voltage is used, the maximum signal output is 10 millivolt, so that the accuracy of 1 microvolt per gram is obtained, and that is too small. Because of that, we use HX711 amplified signal, and it will be has 24 bits accuracy, so that the load cell sensor accuracy can reach 3 milligram. Furthermore, to increase the length of the sample, stepper motor and linear gauge were used. For one step movement, there will be increase in length of 78 micrometer. So the TB6600 module is used to increase the accuracy of the alignation. Using X microstep, the TB6600 module, the increasing length will be 7.3 micrometer. In following hardware diagram, there is a load cell connect to HX711 amplifier. And then it connect to microcontroller to measure the load cell. And then microcontroller will communication with the computer, which is user graphical user interface. And then it will move the motor stepper to measure new force. And this is the graphical user interface. We can set gauge length, sample area, and polling speed, and then stress strain graphic will show in this graph. We can also find ultimate tensile strength and Young modulus. Then the raw data measurement consists in this column. Calibration was carried out using the ISO 7500/1 standard. Mass measurement was carried out at 20 points. The calibration load used has OM F1, M, and 1 class. From the measurement result, the plotting is carried out as shown in following figure. From the graph, linear regression is performed. Error from the sensor reading is obtained from the comparison between the actual mass and measured mass, which is 1 over the gradient. After that, we will do initial calibration was carried out on the tool to compare the actual value with the sensor reading mass value. And in this, we got the result that it has shift about 1.0025. And then we do after that, calibration is carried out using the ISO 75001 standard, and we have an error about 0.094%. And this is the following flowchart of tensile measurement. First, prepared sample on the clamp. Next, the length, sample area, the tensile tests are set. And there is press to zero the mass reading. When press start, the tensile test begin. The stepper motor start to move at the preset speed. The sensor read the tensile mass for the time being. And the data is stored in graphical user interface. When the sample breaks, the stepper motor will turn off. Furthermore, the ultimate tensile strength and Young modulus are calculated. Next, we test was carried out on white paper that is HVS 80 gram GSM. The following results were obtained. We also took measurement on a calibrated instrument and found UTS around 10,700 Newton. And for this apparatus, we found that UTS about 9,921%. From that result, we got the error from finding UTS around 7.28%. This increasedness of error depends on the noise when we do test, because when there is a movement on the motor stepper and will be load cell will be got a noise from the movement. And then we measured nanofiber that we made from ABS, and we find that UTS around 0.65 megapascal, and Young modulus around 11.77 megapascal, and break strength in 10.57%. And that is my presentation. Thank you very much.
Okay, questions for Muzaki from the audience. We have plenty of time for discussion. Okay, how long did it take for working on the instrumentation part of the work?
I started from semester 5, and It finished around July.
And from the calibration, it is shown that the error of the equipment's measurements is relatively low. It's below 1%, right? Yeah. And then have you considered about things that made the system is not going to measure correctly? Do you have that analysis about the things that, well, the equipment that you use currently is going to be used in the proper way, right? But what if there are some conditions that will make the equipments fail to measure? Have you considered any type of situation or variables that need to be avoided when you're using this equipment?
Yeah, there is some avoidment, like if the sample test about 150% of the maximum load cell that we use, and it will be break the load cell. And because of that, I already limited in the program. So when it reach around 10 kilogram, it will be stopped. And then we will do, before using this apparatus, we will do some recalibration, like we will measure the mesh it is still measured correctly or not. Yes, sir.
Okay. What about the sample? Do the sample need to be fabricated into a small pieces, or it need to have some kind of a particular size or shape so that the accuracy will increase, or the measurement will be accurate?
Here is some around the sample, that is when this apparatus is we will use to measure mechanical strength of the nanofiber, and nanofiber is very weak. Because of that, for this measurement, it need what's that, more wide and or more strong enough to be calculated. And or according to the literature, they use around 10 millimeter of wide. So.
Okay. Is there any question from the audience for Muzaki? We have 2 more minutes for having a discussion. Okay, if there are no more questions from the audience, I would like to thank Muzaki for giving a tremendous presentation on the measurement of mechanical properties, which is the Young modulus and the material strength, and so that we could now move on to our final presenter, which is Rivka, going to talk about the analysis of severe accident using particle semi-implicit method.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I'm from Nuclear and Physics Study Program, Institut Teknologi Bandung. Today, I'd like to present my work entitled Analysis of Severe Accident in a Complex System Reactor using Moving Particle Semi-Implicit Method. This is the background of my work. The construction of nuclear reactor is still a matter of concern to the general public, considering the impact during a nuclear I'm sorry, sir. My bad connection. There have been 3 major accidents. They are 3 Mile Island in USA, Chernobyl in Ukraine, and Fukushima Daiichi in Japan. To prevent the accident happening again, research related to reactor design is needed. So the purpose of my paper is to simulate the melting process of the reactor core in a complex system. This is the core of the reactor that I want to simulate. So the purpose, there are reasons why this method is easier compared to other methods. First, it can simulate a phenomenon of flow motion. Second, it can analyze the free surface flow of incompressible liquids without using a mesh grid. So it is very good at simulating the movement of molten fuel in the reactor core. And the last is it can solve the Navier-Stokes equation in Lagrangian framework. The method applied consists of splitting the time into steps and correction. The fluid is represented by particles, and the motion of each particle is calculated based on the interaction with neighboring particles via Carnot function. In this case, we use an incompressible fluid. The equation governing incompressible flow is the continuity equation and Navier-Stokes equation. In the left side of Navier-Stokes equation represents Lagrangian differentiation. The interaction between particles showed as Carnot function, where R represents the distance between particles and RE is an effective range from particle interaction. If the distance between particle is greater than the effective range of particle interaction, the Carnot function becomes 0. So the Carnot function's graph will be like this. The creation of geometry aims to describe the environment of the specified case when the simulation is run. The result of geometry that have been made will be used as one of the inputs for running the MPS application. Geometry can be created in 2 ways, using Microsoft Excel or C++ program. In this paper, I use Microsoft Excel to create geometry. There will be 4 steps in its creation. The first step is set up code page. I will have to open Microsoft Excel and select macros, create a macros name, and the main and the visual will be like this. The main code doesn't exist yet, and we have to create it in the next step. In making source code, I will divide into 3 main areas. A work area is a section to describe the geometry of a particular case that desired. In this case, the index E and G represent the columns and rows in Excel that are used as workspace. Color definition. If the cell in the work area has a certain color that has been determined, then the cell will be described as a particular particle. Color selection is required to be specified, so that can read by the program clearly. This is an example of specific color we can use. The third area is geometry particle arrangement. There are particle type, particle position, particle velocity, temperature, and pressure. After all steps finished, enter the source code in the initial source code page. And the next step is drawing a system. The first step is create an image for a particular simulation by blocking a cell and filling it with the color. After that, press the run button and the output running code will be like this. After doing the pre-simulation stage, the next stage is to do the simulation. When performing the simulation, The initial display that will appear in the open viewer can be seen in figure 10 and 11. The figure 10 is for ordinary simulation and figure 11 for pressure profile simulation. On the right side, there is a table of fluid characteristic that I want to use. This is the water relocation process. Water particles begins to touch the slab in 6 time step, touch the wall at the 10th time step, and touch the bottom of the container at the 13th time step. Flowing water particles tend to be scattered and not closely spaced. When water particles hit a wall or container, the reflection is quite strong. It can be seen in the relocation 13 until 16. The water relocation process takes time 54 until all the particles move to the bottom container. Unlike water, the oil relocation process takes a slower time. It takes 66 seconds. The shape of the flow of oil particles look denser, or the distance between the particles is very close. It can be seen in 13 until 13 time step. When touching a wall surface or the bottom of the container, the reflection of the particle is not too strong. At the end of the simulation, there is one particle that doesn't flow into the bottom container. Next is Candleworks relocation process. It takes time not much different from water. It takes 56 time step. The shape of I'm sorry, sir, my connection. Okay. At the end of the reflection of the wax particle is not too strong when compared to water, but strongest when compared to oil. This is the pressure profile of water relocation process. In first time step, all water particles in the upper container have 4 different colors. Furthermore, in 6 time step, the pressure profile changed into colors, and in 7 until 13 time step, the color returns to vary depending on the pressure obtained. The pressure profile of oil relocation process is same as water at the first time step, but different in the next step. The pressure profile of wax fluid relocation is same as water and oil, and I will describe the color of for variation. The order of colors from the greatest pressure to the smallest is red, yellow, green, and blue. The simulation results of the 3 fluids when all the particles have fallen into bottom container can be seen in table 2. Then from the table, a graph can be shown as figure 18. From the simulation, it can be seen that the kinematic viscosity of the fluid affects the velocity. In the simulation, the slowest flow velocity is oil, while water and wax have almost the same flow velocity. This is following the theory that the viscosity of fluid is inversely proportional to its flow velocity. Because of the 3 fluids, oil has the highest kinematic viscosity value, so oil also has the slowest flow. In addition to flow velocity, the simulation can also see the process of fluid momentum with the slab. from the three fluids, the momentum of the wax particle is strongest. This can be seen in the simulation result using a pressure profile, which shows the color of the wax particles remains variable until the end. Thank you for your attention. That's all from me. If there is a question, please contact me down below. Now I return to Mr. Head.
Okay, thank you, Rivka. Question from the audience. Okay, Rivki, please.
Okay, thank you, Rivka, for your presentation. I have a question for you. As you explained earlier or before, you use the MPS method because this method is the best, you said. So can you explain it what other method can be used in this research? Maybe you can explain it a bit.
Okay, there are many methods for analyzing reactor accidents, such as backward method, LU factorization, and MCNPX, and so on. There is different simulation and different different materials that it used. That's all from me.
Okay, is that answering your question, Rivki?
Yes, yes, thank you, Rivka.
Okay, another questions from the audience, please. Okay, Howda?
I want to ask, from earlier you explained the accident at the reactor core. What is the reactor core? Thank you.
Okay, thank you, Halda, for the question. The core of nuclear reactor is the part of a nuclear reactor that contains the component of nuclear fuel, where nuclear reaction take place and heat is generated.
Okay, thank you.
Okay, more questions from the audience. Okay, in this simulation, Rivka, you practically simulates the water movement from the Navier-Stokes equation, if not mistaken.
Yes, sir. Water,
okay.
Oil, and candle wax.
Okay, is in the equation used in this model, do the thermodynamic relations also included in the simulation?
Yes, it's using Navier-Stokes equation.
Yeah, Navier-Stokes is only for the water, the fluid flow, right? But is it considered that this fluid also have temperature dependence? Was it also included here in the simulation?
I think it's not used of temperature.
Okay, because probably there will be difference between if you are if the water use have temperatures that is too cold or too warm, maybe the mitigation scenario will be different. So since based on what Rivka explained here, that the thermodynamic relation or thermal dependence on the fluid is not included, we could not proceed to any further approximation. Okay, thank you, Rivka, for your presentation. We are at the end of our session. We already have 6 students talking about their selected topic, which are very, very interesting. And I would like to thank all of the presenters of today's session. for giving their best for their presentation. And so we are going to conclude today's session. Thank you all for your attention. We're going to see you again on Thursday for the second session of the final 15 minutes presentation. Okay, let me stop the recording.